Hey everyone, welcome to Securing Your Applications and Azure Kubernetes Service Clusters with Calico and Calico Cloud. My name is Tommy Falgout, and I'm a cloud solution architect for Microsoft in our Global Partner Solutions organization.
My name is Steve Griffith. I'm part of the Cloud Native Global Black Belt team at Microsoft. I work with customers to build solutions around our Cloud Native stack, including Azure Kubernetes Service.
In this talk, we'll discuss the different networking options in AKS, then talk about Calico and Calico Cloud in AKS with a demo, and then show you how to get started. Tigera and Microsoft have been partners for many years, ever since Tigera was listed, or Calico was listed, as one of the options for choosing your own network policy in AKS. This has grown, and this year, Tigera won the Partner of the Year for open source software. Congratulations to Tigera for that huge win. Part of the partnership with Tigera includes Calico Cloud being a preferred solution in the Azure marketplace. As a result, if you're a customer and you have a commitment agreement with Microsoft to spend money, then you can spend some of that money from Calico Cloud against your agreement if you go through the Azure marketplace.
All right, I'll take over from here, Tommy. Thank you. Before we get into what we do with Calico Cloud and Calico within Azure Kubernetes Service, let's talk a little bit about what Azure Kubernetes Service is. So first of all, I think most of us are probably familiar with Kubernetes and the components that are involved, right? So you have your control plane, which includes your API server and scheduler and various components, etcd. And then you have your worker nodes and your node pools, which are responsible for actually executing your workloads, right? So there's a lot of capabilities and components that need to be managed within there. And that's where you might consider using a managed Kubernetes service. So what Azure Kubernetes Service does is it takes the control plane components and delivers those as a managed capability, right? So all of the control plane capabilities like etcd and the API server are fully managed by Azure in a hosted control plane. But your worker nodes and your workloads are run within your network and within your host VMs, which are then managed for you by Azure, but are within your network space. Let's talk a little bit about the network components that are available to you within Azure Kubernetes Service. So first, when you're looking at building a cluster and securing it with network security capabilities, the first capability that Azure provides for you is node pool subnet isolation. So what this allows you to do is take every node pool that you have and dedicate it to a specific subnet. So the subnet isolation gives you low-level, close to the metal network security control that is often required by some network security teams. So you can have, say, for example, your presentation layer running in one subnet, and you could have your database backends and so forth running in another subnet, and have network security rules specific to those at the Azure level. The next would be service subnet isolation, right? So the ability to take that service of type load balancer that you've created within Kubernetes, right? When you create a service of type load balancer, you'll get an Azure load balancer deployed into your infrastructure. That Azure load balancer you can dedicate to a specific subnet. That gives you, again, close to the metal control of the network traffic there. So you could say only traffic from your service subnet is allowed into your node pool subnets, right? Or only specific ports are allowed into your node pool subnets, while your service subnet may allow 80 and 443 traffic. The next one is API server VNET integration. So by default, with AKS, your control plane API server is connected to via connectivity SSH tunnel. So that tunnel allows you that connectivity from your hosted control plane, from your nodes to your hosted control plane. You may choose to actually do a private IP-based connection there, and that's what API server VNet integration does. It gives you a private IP address within your subnet, a dedicated subnet to that hosted control plane. The outbound type control is for when you get to the point where you need to control the flow of your egress traffic from the cluster. So by default, when you create an AKS cluster, all of your egress traffic is going out through the Azure load balancer. So the default outbound type is load balancer. If, however, you'd like a little bit finer grained control, maybe you want to send that traffic out through a NAT gateway because we have a lot of outbound connections and you don't want to run into port exhaustion on your outbound connections. Or maybe you have a DMZ configured for your infrastructure and you want to make sure you route all egress traffic through that DMZ layer. This is what outbound type does. So it allows you to define the direction that your outbound traffic should flow and give you full control over that. For example, some customers that I work with like to send their egress traffic out through their on-prem data center. And outbound type control allows them to do that. So they define a route table that specifies that the next hop for internet egress traffic should go to their on-prem network, and then they can take advantage of it that way. And then finally, Calico network policy, right? So the ability to provision an AKS cluster, and by default, you can have Calico pre-installed on that cluster very easily just by setting the network policy type on the cluster. And that gives you very fine control of the network traffic within the cluster, right? So we've established the hardware level and kind of the Azure infrastructure level network security, but you would likely want to do finer grained control within the network, within the cluster itself, using Calico network policy, along with a number of other features that we'll get into as we continue through this discussion. So as we're talking about those capabilities that Azure provides and the decisions that you make, we've named a bunch of them already, probably the first one that you'll deal with is choosing your network plugin. And Calico has a position in this space as well. So we're going to talk about the container network interface options that are available to AKS users. So the first one is KubeNet. So KubeNet is provided, as most of you probably know, from the Upstream Kubernetes project. It's effectively an overlay network that allows you to create a network on top of your infrastructure for your pods. And it does that by you defining a pod CIDR, so a pod address space. And as you can see here, that pod address space is directly bound to the pod IP addresses, while the node IPs are coming from the subnet, and the service IPs are coming from that service CIDR that you can define as well. Now, an interesting point with this is that the pod CIDR also drives the creation of an Azure route table. So in the upper right there, you can see there's a route table where every node gets a subset of that route table, that pod CIDR. And this is fine, and it does a good job, but it does have some limitations, right? So you can imagine that if you have other route tables within your environment, you can start to run into some challenges. Likewise, if you have very large clusters, the route table does have certain limits on size. So large clusters do run into challenges. So we need some other options. The first one is Azure CNI. So Azure CNI allows you to specify that you want your pods deployed directly onto your Azure subnet. So in this case, you can see both the node IP addresses and the pod IP addresses are pulling from that subnet that the cluster is deployed to. And this is a good option, and it gives you some low-level control over your network traffic for pods. However, it is very aggressive with pod IP address consumption, right? So every pod is going to get its own IP, so you can very quickly run into IP exhaustion issues within your cluster. So as an alternative, we've now provided Azure CNI overlay mode. Right, so Azure CNI overlay mode is an overlay network infrastructure, leveraging some of the backend capabilities of Azure networking. So it's not a VXLAN-based overlay. It's using some other capabilities within Azure to provide this address space. So again, you specify the pod CIDR just like you would with KubeNet, but you're not going to be consuming those IP addresses from your pod subnet from your cluster subnet or anything like that. So this gives you a little bit more flexibility. But again, it's not using VXLAN based or anything like that. So as an alternative to that, we now have as well BYO CNI. So bring your own CNI with Calico CNI allows you to create a cluster and specify that the network plugin, the CNI for that, is none. What Azure will do is it'll provision an AKS cluster and set the network plugin to none, so essentially not deploy any CNI into this environment. And then you can bring your own. So you can deploy Calico CNI and leverage the great features it has there, like IP pools and floating IPs and things like that. So as you can see within this view, the nodes are getting their IP from the subnet, service is getting from the service CIDR, just like it has all the way along. But the pod IPs are coming from the IP pool configuration. So you can see that IP pool is defined and all those pods are getting them from there. So network policy options. So the supported platforms, when you look at these network policy options, the first one's Azure Network Policy, and the second is Calico Network Policy. For Azure Network Policy, the supported platforms are Linux, Windows Server 2022. Whereas for Calico Network Policy, you have Linux, Windows Server 2019, and 2022. So a bit broader support on that side. The supported network options are, the network plugin options are Azure CNI. Azure CNI on the Calico side, you can do Azure CNI for Linux, Windows Server 2019, and 2022, as well as KubeNet. And that's for Calico open source. And then both support the Kubernetes network policy specification, so really no difference there. But where Calico really shines is in this next section, the additional features section. So Calico network policy, and we'll talk about a few of these. One, it provides the ability to use global network policy, which I'll cover a little bit more in detail later. Network sets, eBPF data plane, and WireGuard on your host nodes. And then, of course, you can also enable Calico Enterprise and Calico Cloud, right, which gives you a lot of other capabilities from a portal perspective, visualization, and other things. Let's dig into these a little bit more. So for global network policy, this is a really awesome feature provided by Calico. So typically, Kubernetes network policy definitions are namespace aligned. They're scoped to a given namespace, which means you end up having to create an awful lot of network policies to do seemingly simple things. Global network policy lets you create network policies that span the entire system. And as you can see, you have a lot of options around namespace selection and things like that you can take advantage of. This is an extremely powerful capability when you start to build out complex network environments, or if you just want to establish some very simple baseline network policies that span the entire cluster. This is a really great capability to have. Network sets. So creation of lots of rules for different address spaces and FQDNs can be kind of cumbersome. Network sets allow you for a very simple way to create a network set that contains a bunch of address spaces, maybe a bunch of FQDNs that you can then leverage from a bunch of different network policies more simply. So rather than having to create a lot of different rules for individual address spaces and things like that, you can create very simple rules that leverage the network set. And WireGuard. So WireGuard, this is probably one of the most key capabilities that I leverage with my customers. A lot of customers I deal with are looking for a solution to encrypt traffic between their pods. And often the first thing they look at is service mesh. And service mesh is a great capability and certainly has its place and certainly has its features. But if you're looking at service mesh simply for the purpose of encrypting traffic between your pods, then you might want to look at other options as well, like WireGuard encryption. And you can do that very simply with Calico by setting the Felix configuration to enable WireGuard as true. As you can see here, it's just one command and enables that capability right out of the gate. And you don't need a service mesh to then encrypt your traffic between your nodes. Very simple solution to a problem. And then, of course, leveraging Calico Enterprise and Calico Cloud, you get the great portals. And as I've worked with customers and I've worked on my own to deploy complex network policies into environments, it can be very challenging to understand what the policies are doing, to visualize what the policies are doing. And that's where the Calico Cloud portal really makes a huge difference. You can go right in, you can see your traffic flows, you can better understand what's not working. You can right-click on a pod and get a packet dump directly from there very easily. You can see your flow visualizations. It just makes it dead simple to understand what's going on with your clusters. So I always recommend to customers that I work with, if they start to get into the point where they're building fairly complex or even moderately or not complex network policies, that they want to get into Calico Cloud and take a look at the portal view and see the capabilities and see what it can help them enable on their clusters. With this, I'm going to hand it over to Tommy.
All right. So let's take a lot of what Steve has talked about and see this in a demo. The scenario we're going to walk through is that we have two environments, one production and one pre-production. This could be your staging. And what we want to do is we want to have control over what traffic leaves the cluster. And now we've got this request from our boss to enable the Azure AKS Monitor add-on. But by default, this isn't going to work because we've locked down the traffic. So we'll need to create a new policy to allow this new flow. And whenever we install Calico Cloud, there's some tuning that's done automatically, and we'll walk you through that. So let's go through the demo. The first thing that's going to happen is we're going to add a cluster. So we'll go to Manage Clusters, connect our cluster, give it a name, and then select that this is an AKS cluster. Now, I've already done this on my cluster, so I'm not going to go through the installation process. But you'll be able to see exactly the steps you need to take there. So the next thing we want to do is look at some of the existing policies. There's that egress deny all I was talking about, and that's staged so we can see a little bit more detail. We've allowed DNS, we've allowed Tigera in Calico Cloud, and we've also allowed connectivity, which Steve was talking about earlier, which is used to tunnel back to the AKS control plane. We'll take a quick look at the service graph to get a quick peek that really not much is going on in this cluster right now. And then we'll look at the flow visualization to get an idea of where all the traffic is going and coming from. We'll come back to that later. So now we want to enable the AKS monitoring add-on. This is a very simple command by running az AKS enable add-on and select monitoring. This will go through and deploy some pods into that AKS cluster. All right, we're done. So now let's see what happens. If we go back to our policies, we see that our egress denial has got some traffic that it's blocking. All right, well, this seems to be our problem. So let's take a look at the policy impact. Now, when we go to the policy impact, we can see that some of the traffic that's being blocked is from, at first we see that there is some traffic being blocked. And whenever we dig into it, we can see that it's the AMA logs workloads. So, all right, let's go back to our flow visualization and take a look and see where this traffic is. We see it's in the kube system namespace. And what we want to do is create a policy from this. There's the recommended policy button there. So we'll go through and create this. Now, one thing about this policy that first gets created is that we want to loosen it up a little bit so that it matches exactly what we're looking for, and that we're enable the policy for exactly what we're looking for. And so we delete a few of those labels, and we're going to add a label selector for the RS name. The RS name that we're going to add is for the AMA logs replica set. Now we're going to go down, modify our egress policy. Again, remove some of those labels that might not match exactly what we're looking for. And then update our policy. Or update the policy rules. And now we're going to update our policy. Okay. So we've now created this new policy for what we're looking for to enable and allow those the AMA logs. And we're going to go back to our egress policy. If we go back there, and if we take a look again at our impacted traffic, give it a second for it to load through, and then we'll see that our impacted traffic has gone away. So there's now no more traffic being blocked, and we're good. I'll let Steve take us home.
Thanks, Tommy. Okay, let's take a look at creating a cluster using CNI NUT. So we're going to create an AKS cluster that has no container network interface implementation deployed. It's not using Kubernetes, it's not using Azure CNI. And then we'll go and deploy Calico CNI on top of that cluster. So to do that, the first thing we need to do is we need to set a few environment variables, or at least I'm going to do this just to make it a little bit easier. All right, so I'm going to set what the resource group name is, where this cluster is going to get deployed in Azure. The location, so the region, I'm going to go to East US, but you can really go anywhere. The cluster name that I'm going to use, which is just demo cluster. All right, so now let's go in and we'll actually create the resource group. Okay, resource group is created. Now, for my purposes, I'm going to create a VNET in advance. If you don't specify a VNET and subnet on your cluster creation, AKS will create one for you. But in my case, I want to go ahead and create one in advance. So you can see here, I'm just doing VNET create, telling it what resource group to put it in, giving the VNET a name, telling it what the VNET address space should be. And then I'm creating a subnet within that VNET specifically for use for my AKS cluster. So I'm going to deploy this and make this a little bigger so you can see. That should go through pretty quickly, and there it is. Now, to deploy my AKS cluster into that subnet, I need to know the FQDN, fully qualified name of that resource in AKS or in Azure. So I'm going to go and use this quick query to pull that value. So this is just doing a subnet show, querying out the ID of that resource. Okay, so I'll grab this. I'm just going to set that into an environment variable. Okay. So a little further, let's clear this. We can take a look at that value. We'll just do an echo. Yes, subnet ID. You can see there's that fully qualified resource ID. Okay, now we create the cluster. So to create the AKS cluster, we're going to run our AZ AKS create. This all could obviously be done through Terraform or Bicep or ARM, whatever your preferred mechanism is, but this is just for demo purposes. We'll show it here. So I'm creating the cluster. I'm telling it the resource group to go to, telling it the name I want for the cluster, telling it the subnet resource ID. And then finally, the most important part here, I'm setting a network plugin value to none. So that's going to tell AKS when it provisions not to bother deploying any CNIs to this cluster. All right. Okay, this will take a maybe 2 minutes, 3 minutes. So we'll do a quick time shift here. Okay, our cluster was created successfully. Let's go ahead and get the credentials and take a closer look at the cluster. So here I'm just going to use the AZAK escape credentials command. And let's explore this cluster a little bit. Okay, so first let me take a look at nodes. So you can see here, the cluster has 3 nodes, and none of them are in a node ready state. Right, so they're all 3 are showing as not ready, which makes sense. We haven't deployed a CNI to them yet. Let's take a look at the pods that are running there. And again, I'm going to go out wide so we can see the IP addresses here. Okay, so you can see we do have pods that are deployed successfully. They're up and running, but there are a few that are in pending state. So the ones that are running successfully right now, as you take a look at their IP addresses, you'll notice those IP addresses are coming from the node directly, right? So these are all pods that use host network in the pod spec. So they're all jumping on the host network interface rather than doing a CNI connection. The ones that need CNI, metric server, core DNS, are in pending state waiting for that CNI to be installed. Before we install CNI, let's take a look at this in the portal, see what we see there. So first off, I jump to my resource groups and take a look at my my demo. Let's search here for CNI. All right. I can take a look at my virtual network. On virtual network, I can check the connected devices and see I just have my 3 nodes connected there. Okay, with Azure CNI, you would actually see a good bit more here. The kind of standard Azure CNI, you'd see a number of IP addresses associated here. But in this case, we're only using 3 IP addresses from that subnet. If I jump over and take, again, look at my CNI resources, I can jump to the Managed Cluster Resource Group. So we mentioned earlier in the presentation that AKS manages the control plane, but there are other resources that are deployed into your subnet that are kind of visible in the customer subscription. So if you take a look here, this MC_resource group, I can see a few things here. I can see a managed network security group. I can see a managed route table there, although there's nothing in this managed route table, right? Whereas with KubeNet, we would have seen additional items in there. And we can see the VM scale set and things like that. This Azure load balancer we discussed earlier as part of the outbound type configuration, right? So if you leave the default outbound type configuration as load balancer, then you'll get a load balancer, and the purpose of that is to give you that outbound connectivity. So take a look at the outbound rules. You can see I have an outbound rule as well as a front-end IP configuration that's used by that outbound. So that's the outbound IP address of this cluster. Okay, so everything looks good, except that we don't have CNI running here. So let's go and do that. So let's scroll down a little bit further here. First thing I'm going to do is install the Tigera operator. This is all available on the Tigera Calico documentation, how to do this, but we can just grab the commands from this presentation. Okay, so that was deployed successfully. Next thing I need to do is install the configuration, right? So the configuration for this is going to specify, that the Kubernetes provider is AKS. It's going to specify what the IP pool that we want to use is. So this address space is what our pods are going to use for their IP addresses. And it's going to set the encapsulation as VXLAN. So let me grab this configuration. And again, this is available on the Tigera documentation. Okay, let's clear this. Let's watch as the pods come online. All right. So you can see the Calico nodes coming online here. Once they come online, what you start seeing is these IP addresses that are none. You'll see those start to get populated. These pods will come online and they'll get their IP addresses from Calico CNI. So the Calico Kube controller is just starting up now. You can see a couple IP addresses coming in here. So again, that's coming from that 192.168 address space we specified in the IP pool configuration. Now, if I minimize this, let's clear this. I'm going to actually deploy another workload here, just so you can see. Okay. Oops, let's actually go wide on that so we can see the IP address. And there again, you can see I deployed a workload, and you can see the IP addresses there are coming from that IP pool above, the 192.168.0.0/16. Okay, now if I jump back over the Azure portal here, and let's go back, we can take a look at this route table. And again, with KubeNet, we would have seen addresses in this. We would have seen route configuration specifying chunks of the pod CIDR that needed to go to which nodes, which we're not seeing here. All right. Now, since we've done this, we're running with Calico CNI. Let's take it a step further. Let's enable WireGuard. So we talked about this earlier, how simple it is to enable WireGuard encryption. So I'll deploy this, just running a quick patch. WireGuard enabled equals true. And that's it. WireGuard's now enabled on this cluster. We can take a look at it just to be sure. So I'm going to grab a node name. I'm just going to grab the first node that comes up. All right, so if I echo node name, you can see that's just one of my nodes. I'm going to run debug pod on there. Okay, now let's chroot /host. Now let's take a look at the interfaces on there. And specifically, I'll take a look at the WireGuard interface. And there you can go. There you go. You can see that the WireGuard is running. You can see if I keep checking, there's more traffic that's starting to come through there. You can see that the TX packets is going up. Slowly, there's not a lot of traffic in this cluster, but you can see that the traffic is going through WireGuard encryption at this point. So I think what was really interesting with that presentation, with that demo, is that you often have new capabilities that are being added to AKS or new features you want to leverage from the cloud native ecosystem, and it's really good to have a staging environment, a place where you can test those things out and figure out what your network policies are in advance of trying to get that through to production. And the capabilities that Tigera and Calico provide around the staging of those and being able to visualize the traffic and getting recommendations of what the policy could look like make that so simple. I've spent hours and hours trying to unwind network policies manually to try to figure out why my GitOps isn't working, or why this specific agent can't communicate externally because it's hitting all these various different ports. And this makes it so simple to figure that out. So to kind of recap here, we look at the features that AKS provides and the capabilities that Calico enables on top of that, between the ability to isolate your node pools across various subnets, isolate your load balancer subnet, your API server, control your ingress and egress traffic flows at a low-level network security group layer and using route tables and things in Azure. And then you supplement that with Calico network policy inside the cluster to give you really fine-grained control of the traffic that's going between your pods, between your nodes, coming into your cluster, leaving your cluster. These things all work together to give you the most secure network environment that you could possibly have within AKS. With that, thank you so much for hearing us and listening to our session here. Thank you.
Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the Scan Results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure and does not have any misconfigurations. Calico helps you continuously assess your Kubernetes configuration using compliance reports that assess your configuration against CIS benchmarks. I scheduled my CIS benchmark report to run every 24 hours. The number of nodes passing or failing the CIS benchmark tests is color-coded. And here are the top failed tests. I can also download the full report to get more insight on each test and how to mitigate its risk. At this stage, I have scanned all my images, allowed the deployment of only those that pass the security requirements, and I have also assessed my deployment environment against CIS benchmarks. Try it yourself by signing up at www.calicocloud.io. Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the Scan Results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure and does not have any misconfigurations. Calico helps you continuously assess your Kubernetes configuration using compliance reports that assess your configuration against CIS benchmarks. I scheduled my CIS benchmark report to run every 24 hours. The number of nodes passing or failing the CIS benchmark tests is color-coded. And here are the top failed tests. I can also download the full report to get more insight on each test and how to mitigate its risk. At this stage, I have scanned all my images, allowed the deployment of only those that pass the security